And please help me welcome Professor James Instrom, who will introduce our featured keynote speaker for lunch. Professor Instrom.
Thank you very much. I am honored to be able to give a short and specialized introduction to Dr. John F. Clauser. And I am pleased to have been able to introduce John to DDP. John received a BS in physics from Caltech and an MS and PhD in physics from Columbia University. He spent much of his career affiliated with the University of California at Berkeley and its national labs. He did brilliant research in the early 1970s showing that quantum entanglement allowed particles such as photons effectively to interact at great distances, seemingly to require communications exceeding the speed of light. His seminal 1972 experiment has been described as one of the most incredible intellectual achievements in the history of science. For this research, John was awarded the prestigious Wolf Prize in Physics in 2010, and along with two others, the Nobel Prize in Physics in 2022. However, I believe his most important contribution at this time is his outspoken support for honesty in science, such as the talk he is giving today. I conclude with a few facts that are not in his official biography. John's parents were introduced to each other by Nobel laureate Linus Pauling at Caltech, and John's first job was working for Pauling. John was a classmate of Art Robinson at Caltech, and Pauling played important roles in Art's career. John is only the second physics Nobelist born in Los Angeles County. He still lives in California, and his outspokenness is helping diffuse the climate alarmism that is promoted in crazy California. Please give a warm welcome to Dr. John Clauser.
Thank you, Jim. Okay, this is really two talks kind of put together. I've got them in the reverse order here. The first talk is kind of introduces the really important one about what is really going on. Okay, so, oops. Got it. All right. Okay. The first talk is basically that I believe climate change is a total myth. Put forward by the IPCC and its collaborators. They were tasked with some very important tasks which I believe they botched. The first one of which is to identify the dominant process going on in the Earth's atmosphere. That I will cover in part 2 of the talk. They have been tasked to use computer modeling and observational data from satellites and ocean buoys to measure 3 important numbers. They were tasked to measure the Earth's so-called power imbalance. And secondly, they have been asked to measure the so-called feedback stability strength. These are very important numbers. And they've also finally been asked to determine what is the Earth's albedo. I'll get into the details on all of these. I claim that all of these were botched. Worse yet, I believe this was done with dishonestly and intentionally erroneously fudged data. It's not easy to say that to other scientists. As a result, the whole argument, I believe, is totally bogus. Okay, the first of these. The first sacred task is to calculate and measure the Earth's power imbalance. What is the power imbalance? Okay, it is the difference between the incoming energy and the outgoing energy. Okay, the incoming energy is sunlight. The outgoing energy has two parts: reflected sunlight and far infrared heat, radiation. So if we have more power coming in than flowing out, there's a buildup of energy. And that is actually the IPCC's definition of global warming. I'll get into that later. If you have a buildup of energy, you will get a temperature rise. So they have been tasked with calculating and measuring this power imbalance. This is why it's great importance. And they have claimed with great certainty that it has a proven net global warming, a proven net power imbalance. It claims there's more sunlight power going in than is leaving. Based on this, they built a whole house of cards. I will get into that. I believe the whole house of cards totally collapsed, and the end of the top of the is in a total apocalyptic prediction. One important thing is they drew their conclusions before they looked at the data. So, what is this house of cards I'm referring to? Okay, if you can prove global warming warms the atmosphere, stirs up the atmosphere, etc., and it leads to climate change. If you have climate change, it's all of a bad kind, usually. That's at least what is worried about. That there's an increased frequency of extreme weather events. An increased frequency of extreme weather events, in turn, leads to global apocalypse. Worse yet, the National Oceanographic and Atmospheric Administration, NOAA, claims to have actually observed this increased frequency of extreme weather events. The IPCC further claims they know the cause of all of this power imbalance. It's due to buildup of atmospheric greenhouse gases. And so their basic conclusion is, give us trillions of dollars to spend to limit greenhouse gases. Okay, I assert that it has not proven global warming. All of the power imbalance and observational data are completely, fully consistent with no warming. I assert that their further claims of the power imbalance are based on dishonestly fudged data. Computer modeling has been discussed before. I'll go a little bit further into it. And it uses very seriously flawed physics. Now, I mentioned NOAA. NOAA has claimed to have observed an actual increase. I will show you here that their own data disprove their own claims. So, what happens? Without global warming, there's no climate change. The whole house of cards collapses. Moreover, the requested trillions of dollars are a total waste. Okay, let me start with the computer modeling. This was done mostly by the Goddard Institute for Space Studies, which I'm now embarrassed to say is where I wrote my PhD thesis. is totally incapable of simulating the past history, for which it has all the data. So if it can't do that, there's no way that it's going to predict the future. And they do that for the temperature history. More importantly, when you not pointed out earlier, I found out recently that their attempts to model the Earth's albedo are way off. And finally, when you use their own data and you just simply apply conservation of energy, you find that their estimates of the albedo of clouds is wrong by a factor of 2. Okay, let's look at some of these. This was first pointed out in a very important recent book by Steve Koonin, who was Obama's White House science advisor. Book is Unsettled: What Climate Science Tells Us and What It Doesn't. Okay, so here, this is actually a graph that was taken from AR5 and actually reproduced on the back of the APS, or American Physical Society News editorial page. Okay, the gray stuff on the left, okay, over here, okay, the gray lines are their attempts to simulate the past. They can't simulate, okay, the black solid line is that what they claim the actual measurements show. They can't even simulate the past. If you can't simulate the past, all of these colored lines here are their predictions of the future. You can't trust them either. There's not a single one of their 40-odd many plus models that is capable of simulating the Earth's past, let alone predict the future. Now, one of the other pieces of bad science here is they don't plot the temperature. They plot this so-called temperature anomaly. What the hell is that? I haven't the faintest idea, because they never tell you what the reference value for 0 is. So if you don't have that, there's no way you can cross-check it with previous reports. There's no way you can apply the Stefan-Boltzmann law to calculate the power output. It's totally meaningless. Worse yet, we have such a terrible disagreement between theory and experiment. It shows that there's something very wrong with the physics that they put in the model. Okay, well, using temperature anomaly, or even just temperature, is actually a very poor estimate of global warming. It's kind of mixing up cause and effect. The cause is the power imbalance, and the temperature is the effect. The problem is, and this has been talked about earlier, it strongly varies from point to point. We have the urban heat island effect, etc. And worse yet, almost all of these measurements are made over land, and land is only 30% of the Earth. The oceans are the majority of the Earth. You could be silly to ignore them totally. Okay, so the IPCC actually agrees with this, and so you can only have one definition in proper science, and they agree that the proper definition of global warming is more power coming in, or more power coming in than going out, that there's a power imbalance. And an important part of that is what's called the Earth's albedo. What is albedo? Well, it's just a fancy word, which is the reflectivity fraction of the Earth, of sunlight. So it's the ratio of the reflected sunlight to the incident sunlight. It's a very simple number. Okay, measuring or calculating it equivalently, measure the power imbalance is perfectly equivalent to measuring the Earth's albedo. And corresponding to any errors you make in measuring the albedo represents an error in the power imbalance that you calculate. Okay, earlier I was showing you the various models were the CMIP-5 model sequence. Okay, this is a more, I'll show you a more recent published article. It shows that they are totally incapable of getting anywhere near simulating the Earth's albedo. And that their error is about 14 times bigger than their claimed imbalance range. Again, we have serious disagreement. Okay, this was published in 2015 by Stevens et al. This is the annual variation. It isn't, by the way, it isn't constant in time. It varies quite significantly in time. This is average of about 10 years of data from the Terra and Aqua satellites. Okay, the colored curves are their predictions. The black curve are from the Terra and Aqua satellites that have measured. I mean, they're off by 10, 15 watts per square meter. Okay. Okay, so I have added this left-hand scale just simply by multiplying albedo times the solar constant, 340 watts per square meter. And you can see that the difference between so the average is, as everybody seems to claim, about 100 watts per square meter squared of the outgoing, the reflected sunlight. And the assumption here is that the solar constant is constant. It's not. I'll get to that later. Okay, so the modeling is clearly incapable of simulating the experimental data. And they can't even get the phase of the oscillation right. Okay, and so and their errors are huge. Now, Stevens et al., he's the author of the bad penny. I will come back to the bad penny in a minute. And I note that the latest assessment report, AR6, has never heard of this paper. Okay, so the bottom line, also part of Stevens et al., the bottom curve here, this one is the solid line, that's how much the incident sunlight varies annually. This is just simply due to the ellipticity of the Earth's orbit. It's sometimes closer and sometimes farther away, and that's how much it's varying the order of 22 watts. So you have to add that on to the earlier large fluctuations in the actual outgoing solar power. Okay, so measuring the power imbalance should be easy. Okay, we define it as more power coming in. That's okay. Typically, that's on average that's about 340 watts. The climate scientists all refer to that as shortwave radiation. It's sunlight. And it varies by about plus or minus 11 watts. Okay, the power out's got two components. There's 100 watts reflected and about 240 watts of re-radiated heat, also known as far infrared. Okay, just measure in and measure out. Simple enough. No, it's not at all simple. These are very big numbers. And if they have even a minor error, those errors, okay, the difference between them is about 0.2% of the incident power. So any small error you make in any of these powers shows up in the final difference power that you calculate. The people who, the poor suckers down in the lab who are asked to do this, the satellite data, they throw up their hands and they even admit in print that the satellite radiometry and the ocean heat content buoy data are totally incapable of measuring to this accuracy. And their sampling just grossly violates Shannon's sampling theorem. But nonetheless, they had to publish something. So they did. Okay, so how did they do this? Well, they had early on, okay, this was first done by satellite radiometry. First was a rather crude satellite that went up rather quickly, the Irby satellite. And then the Terra and Aqua satellites were very sophisticated satellites, which were finally took data long after the IPCC had drawn all of its conclusions. There's also measured by the ocean heat content as a measure of the power. And that was done with the Argo buoy chain, also grossly undersampled. And they're also just simply the water sampling where the guy throws a bucket over the side and sticks a thermometer in it. It's rather crude. And there's another group which was the baseline surface radiation network, where they had a whole array of radiometers on the ground looking up and measuring the sunlight when there were clouds present and when there weren't. Now, all of these were grossly undersampled. They are huge data gaps. In doing good science, fabricating data to fill in the gaps is one of our little no-nos. Worse yet, adjusting. I call it fudging the data. Willie Soon mentioned first talk yesterday that they did this also with the temperature data. They just simply adjusted the numbers. And worse, in this case, they simply took data that showed no warming and just simply erased it and put in data that showed warming. Okay. So where does one get these in their publication? Readily available. If you just grab their, get their reports, they all produce what's called a power flow map. And just the top line, you can pull the numbers off. There are only those three numbers that I mentioned earlier. And if you don't believe what I'm saying here, that they're visibly fudging, I suggest you just simply read the numbers off the graphs that I show, which I just photocopied. Okay, so what's the calculation one needs to do? It's very, very simple. We just take power in, the first line. Okay, power in minus power out, and we get the imbalance. The calculating the error bars is just a straightforward root mean square sum of the input error bars. It is worth noting that this automatically provides you with an instant cross-check. You can just see whether or not they're cheating just by looking at the final error bar of the power imbalance error bar has to be greater than any one of the component. That any single large fluctuation has got to show up in the final error. So how do you determine if there's global warming? Well, if the imbalance is less than the error, there's no global warming. If there's an imbalance, it's greater than the error, then we have an imbalance. Okay, the earliest two reports. First one was in 1981 by Stevens et al. And the second one following him was by Ramanathan in 1987, who was at NCAR. Okay, so these are the numbers they use in their sum. Okay. The red number is what they report the arithmetic shows. I calculate the black number. Correspondingly, at least Ramanathan gives you the right number, but then I calculate it as -3. Okay, so here is the Ramanathan's power flow diagram. Here you have your 343 watts coming in here, 106 going out, what is that, 237 going out. Okay, the U.S. National Academy, in their report on understanding climate change feedbacks, reviewed this, and they said the observations do not meet quality standards. Now, one of the important things that Ramanathan did was that he divided the whole sky up into two distinct portions: cloudy sky and clear sky, nothing in between. Partly cloudy just didn't exist. But that whole definition strategy has been used pretty much universally ever since. Okay, Loeb et al. He says right up front, he says, a limitation to the satellite data is their inability to provide an absolute measure of the net top of atmosphere radiation imbalance to the required accuracy level. So what's he do? He takes Ramanathan's numbers and he just simply erases them and puts in new numbers in here, says, well, here's what they need to be. Okay. And his new values now show warming when Ramanathan's didn't. Okay. And the way he justifies this is he says, well, we don't really believe satellites, so we're going to change their numbers, and we're going to get what we believe to be true from the ocean heat content data, which is measured by this chain of Argo buoys, where they just simply sample the water temperature. Now, this was all, sounds like it was forced upon them. I don't know the history of the politics, by speculation by Hansen et al. Okay, so here are Loeb's numbers. Okay, again, I mentioned that they have the Argo data was terribly undersampled, gross violation of Shannon's sampling theorem. Nonetheless, okay, so what they do, they had Lyman and Johnson, who even published how they did it, how they just simply fabricated data to put in. That's one of our little no-nos. Okay, so we have, here's the Uribe satellite. Okay, calculate cooling by 1.6. Here, the ocean heat content, they switched to plus 0.9, which is warming. And they somehow, then they throw out a whole bunch of additional numbers and say it's 0.64 plus or minus 0.11. They never show you where they get that. I refer to this as the bad penny that will keep showing up again, because it does. Okay, So they admit, yeah, we did adjust the numbers. Yeah. It's like the line from Monty Python's Holy Grail. Yeah, we did put a carrot on her nose, but she's still a witch. Okay, so they use visibly incorrect arithmetic, and they don't even tell you how they calculate their error bars. And what? Okay, this is Stevens et al. In 2012. And so here is Stevens et al. Power balance diagram. So this is the origin again of the bad penny, which where he just takes Loeb's error bars and increases them a little bit. Okay, and here they're attempting to agree with the CMIP5 calculations, which are they show here. Oops. Okay, here, these are the CMIP5 results. And right on their slide, the arithmetic doesn't add up. Okay, let's see, did I skip a, yeah, here is, I skipped this slide, sorry. Okay, so here is where they, those numbers that they got off of that power flow diagram are. Here, these are the numbers that they use, and they pull those right off their diagram. I add those numbers, and I got 0.5 plus or minus 4, effectively. They say it's 0.6 plus or minus 0.4, the bad penny. Oh, don't worry, it gets worse. Okay, Lecoyer. Well, okay, Stevens and Loeb, for that last paper, they kind of joined forces to produce that. One of the authors was Lecoyer. Lecoyer decided, apparently, that he was going to do a minority report. He was unhappy with the way they handled the numbers. So he then, Lecoyer and his group, reanalyzed the ocean heat content data from the buoys, and they revise Loeb's revision, and here they come up with no warming. They do say, well, we're going to use constraints. They don't tell you exactly what the constraints are, but nonetheless, either way, they still find no warming. Here's their power flow diagram. We have, again, the same place. Here's the incoming solar, here's the reflected solar light, and here's the outgoing radiated far infrared heat. Then along comes the first whistleblower, Trenberth. Trenberth and Vasulo wrote the first paper in 2010. Okay, so what was kind of wrong, a little bit wrong with what Loeb and Stevens were doing? The satellites all measure, we need a consistent altitude for definition if we're going to handle a power imbalance study. Okay, and that has been by convention defined to be the so-called top of atmosphere. So the satellites are all measuring stuff at the top of the atmosphere. There are other measurements, like for example the ocean heat content, which are at the surface. Now you can't mix up apples and oranges and use some from the surface and some from the top of the atmosphere. And so this is what Trenberth et al. Point out. They're very critical of the work done by Loeb, Stevens, Lecoyer, and Hansen. And they noticed that there's a huge discrepancy between the total energy, between the ocean heat content and the satellite data. And they ask, where does the energy go? That has never been resolved. I personally strongly suspect it goes into speeding up the rotation rate of the Earth, because the actual, it is visibly observed to be speeding up. If you look at compare the astronomical time to atomic clocks. Okay. So Hansen he dismisses this, and he says, "Oh, it's just satellite calibration errors." So Trenberg, Fasula, Balmasada note that there are still major unresolved errors. So these were the first whistleblowers, and my hat is off to them. Okay, remember we had a disagreement to some extent between Stevens and his minority report by LeCoyer. So Stevens, well, this is kind of festering a little bit. So Stevens and LeCoyer decide they're going to jointly author a paper in which if you read it, it is literally a mea culpa, where they claim to have made unjustified ad hoc choices between ocean heat content and the satellite data. So what do they say? They're both right. So yeah, they admit, well, yeah, we did need to make adjustments. I call them fudges. And these are big, at least 10 watts per square meter. And guess what? We still claim in the line 5 of the abstract, it's 0.6 plus or minus 0.4, the bad penny. Okay, and here is their power flow diagram. They show, you'll notice each line has 2 power flows, input powers, one from the satellites and one from the buoy data. Okay, so here is how they show their numbers. Okay, so they have the ocean heat content. Guess what they subtract? They get 0.6 plus or minus 0.4, the bad penny. And they say that's true for both of them. I calculate those at 0 plus or minus 5.6. Okay. This goes on. Wild et al. He analyzed this baseline surface radiation network and got a very good measurement of the clear sky albedo. And he produces, Wild et al. Produce their own new power balance, power flow map. And 2 years later, the grand official AR6 assessment report makes an almost exact copy of that. It adopts that as the gospel. Okay, so you notice, again, all you have to do is just look at the top lines here. Here's your 340 coming in, 100 going out, 240 or 239 going out here. Same thing here. For this is the Wild et al. And here is the AR6. You'll notice, and down here, inconspicuously in the corner, they show the power imbalance that they calculate. So all the numbers are right there up front. Okay, here is how they do their arithmetic. Okay, so Wild et al. Claim the bad penny, 0.6 plus or minus 0.4. Okay, I calculate this 3.5 plus or minus 0.6 just for adding up those numbers. And I urge you to do the same if you don't believe me. Okay, and so AR6, well, they got to tweak that a little bit. So they say it's not 0.6, it's 0.7, but it's now plus or minus 0.2. They cut the error bars in half, and actually they've cut it by a factor of 4 because they say, well, these are really 2 sigma error bars. Okay. And again, all of these, if you do the simple RMS sum cross check, they all flunk. Okay. Now here, the Vilde et al. Introduces a neat new trick where he shows the error limits rounded off. And the round-off error for those numbers is half a watt per square centimeter, which is the same order of magnitude as their imbalance. Okay. There are 2 important things you need to note. Let me back up here a minute. This line right here on both of them, this is the power for evaporation of water. Okay. The second one is, well, let me go back. The first thing that I will point out is that we can calculate the cloudy sky albedo, and that's off by a factor of 2, just from Vilde et al. The second thing is looking at that power to evaporate water. That is 73% of the usage of sunlight power that is incident on the ocean. This is clearly the dominant process. 73% of all the sunlight that falls on the ocean is used simply to evaporate water and not to warm the planet. And the oceans are 70% of the planet. Okay, so how does one calculate the albedo error? That's pretty straightforward. There's a very simple energy conservation law one can make, which is the albedo so you have 2 composite areas, all sky, or cloudy sky and clear sky, that the average albedo for the whole sky is just the area-weighted average of the 2 areas. Okay, so if you're using the AR6 all sky diagram, you get the standard number for the all sky albedo 0.3. That's the reflectivity of the Earth. The clear sky, you can just get that it's 0.33. Okay, so if you have 2/3 cloud fraction, everybody seems, for the whole Earth, everybody agrees on that. That gives you a cloud albedo of 0.36. You can just fly over clouds at a DC-3. In fact, that has been done, especially the Pacific Ocean stratus, which are most of them, and you get a number at least twice that. Something is clearly very wrong. Okay, so you may ask, what does sunlight actually do when it gets to the Earth? Well, over Earth, it's probably true. Most people believe that it warms the Earth. That's over land. Land is only 30% of the Earth. 70% is ocean. And virtually all of the Earth's exposed water is in the ocean. Virtually negligible portion is in lakes on the land. So if you look at their power flow diagram, they show 160 watts absorbed by the whole Earth. 70% of that is 112 watts. That's how much is absorbed by the oceans. Okay, so we saw that 82 watts was used for evaporating water and not for heating the earth. That's all mostly done over the ocean. Now, well, if you left out the fact that it was all over the ocean, then more than half is used for evaporating water. But if you just look at the ocean alone, you have 73% of the energy is used for evaporating water. So it's clearly the dominant usage of clouds. Before I leave the cheating by the powers that be, I mentioned before Noah had claimed to have observed an increased frequency of extreme weather events. They published this in Physics Today in 2012, predicting and managing extreme weather events. This was done by, the authors were not scientists. Why Physics Today allowed this, I don't know. Jane Lubchenco was Undersecretary of Commerce for Climate, and Thomas Carl was NOAA's Director for Climate. Okay, so they claim that it is obvious, in fact they do this right up front, they say, well, it's obvious that in the last 3 decades, there's been a huge increase in the frequency of extreme weather events. They give you, create an index of extreme weather events. It consists of some composite, they don't tell you how they weight them, but number of hot spells, number of cold spells, number of droughts, number of floods, number of landfalling hurricanes. They leave out, by the way, EF3 plus tornadoes, because that would push it the wrong way. As Steve Koonin points out, actually those are decreasing, so we can't include those. I assert that, they assert that it is obvious that there's an increase in the last 3 decades. Here is their data. They copied right off. I learned from some people who knew what they're doing when I was at Cal, Charlie Towns and Louis Alvarez. Alvarez would look at that and say, flattest line I ever saw. And Charlie Towns would say, I don't see in the data what you're telling me I'm supposed to see. So I looked at that and I said, well, okay, what can I learn from that? So I took their data and I plotted it twice. I just plotted it, nobody uses bar graphs, that's very hard. So I just simply replotted it as a point graph, and I plotted it twice, and one of these is left, right, reversed. If you look carefully, you will see that they are exact mirror images of each other. I will assert, if you can't tell which way time is going from looking at the data, then it is not obvious that there's an increasing frequency in the last 3 decades. Okay, so what are my conclusions from part 1 of this talk? The IBC and its contributors claim that there is a net warming imbalance. And they define net warming imbalance as being a definition of global warming. If you don't have a warming imbalance, there's no global, there's no crisis. They claim their computer models can simulate with great accuracy the observational data. No, they obviously can't. The modeling is totally unreliable. Not one of the, moreover, if you look at the observational data, not one of the various modalities from satellites, ocean heat content, shows a net global warming. These observations have occurred over and over and over again. This cannot be done unintentionally. This is clearly dishonest fudging of the data. If you don't believe me, just redo the arithmetic yourself. It's very easy to do. So it's another conclusion. There's clearly a very serious factor of 2 error being made in the cloudy sky albedo. So another conclusion: NOAA have claimed that it has already caused extreme weather events. Their own data disprove their claims. So what I have, I believe, is great news. And the people are going, those will be angry with me for giving out good news. There is no climate crisis. The planet is not in peril. And their claims are a dishonest hoax. Okay, 2, 3 important little ones. The oceans are 70% of the Earth. 73% of the sunlight hits them is used for making clouds. This has got to be the dominant process. Okay, I mentioned the error in the albedo. Okay, so let's go into part 2 and ask, well, what is really happening? It's pretty clear that the IPCC is clueless. What's their second task was to identify this process. I claim they have not done so, and they incorrectly scapegoat greenhouse gases as being the dominant source. And they use fudge data in order to make this claim. What I claim is happening is what I call the cloud thermostat mechanism. It provides an extremely strong natural feedback mechanism, provides the Earth with very strong temperature and climate stability. The feedbacks that are associated with greenhouse gases are totally negligible. And I'll show you the numbers. As a result, the Earth is very robustly stable against perturbations, everything from greenhouse gases, volcanism, etc. Where does it get all this great power? It gets its great power from the huge variation in the cloud cover of the Earth, the cloud coverage. The cloud cover fraction varies tremendously, and I'll show you direct measurements of that. So it's just like the thermostat in your home. Power imbalance is never zero. The furnace is always on or is always off. The thermostat, all it does is it just modulates the duty cycle of on-off. Okay, so the furnace here, okay, is the reflectivity of the sunlight hitting the surface of the ocean or not hitting the surface of the ocean. Clouds provide dark shadows, and they either, once they shadow the ocean, no light there effectively, and that turns the furnace off. So the fluctuations in the clouds is that they are modulating their own cloud production rate by that mechanism. So we have the fact we have huge variation in the light anywhere from 18 to 55 or 40 to 77 watts per square meter, including the gives this a very powerful, gives you a very powerful furnace. So they modulate the reflected sunlight power, and thereby they control the power imbalance. So they've got this huge amount of power to do this. It's the modulation strength is like 26 times this wimpy 0.7 watts power imbalance at the IPCs, and it's 45 times bigger than their claimed error range. And if that's just assuming the IPC sees very questionable measurements of the cloudy sky albedo. It's more like 100 to 200 times bigger if you include a more reasonable estimate of the cloudy sky albedo. So the seemingly random fluctuations, clouds are kind of random, right? Some of them look like bunnies, who knows? Okay, the seemingly random fluctuation becomes fairly clear that it is not random at all. It's actually a crucial part of the feedback mechanism that's controlling and if you look at data I will show you in a minute by King et al. And by the ones we saw earlier by Stevens et al., that it is quasi-periodic. Okay, so what are some underappreciated properties of clouds? You can just ask a very simple question. What does the Earth look like when viewed by the sun? The illuminating source, okay? These are some pictures. So the left-hand one is the famous Earthrise by the astronauts of nearly cloudless Earth. Going from left to right, we get higher and higher cloud fractions, especially the right hand is over the Pacific Ocean. We got lots and lots of clouds over the oceans. So one thing immediately obvious is that the cloud coverage area is highly variable. The second thing you notice is clouds are all bright white. They have a very high reflectivity. They dramatically reflect much more light than the ground or the ocean next to them. So for comparison purposes, a sheet of white paper has about 99% reflectivity. So if you look at that just visually, you say, well, that's got to be about at least 80% reflective. Now remember that the AR6 and Bill et al. Claim that the reflective is only 0.36. It's barely any bigger than the whole average. Just looking at the pictures, it's obvious the clouds are obviously a lot whiter than the average. Second thing that you notice, just flying in right into El Paso Airport, it was very clear. You're in an airplane, you look down, and the clouds cast very dark shadows, practically black when you're looking at them. Actually, they are blacker than they look. These are very sharply defined shadows, you can see. Or you can see the same thing if you drive on a hillside and look down in a valley. You can see the cloud shadows. They've essentially turned off all the sunlight below them. And it's actually in a partly cloudy sky. They're actually darker than they look because the blue sky Rayleigh scatter, it's got 1 million times more solid angle coming in, so than the sun itself does. So even though it is not as bright, it's sending in a lot of light, and it illuminates the land inside the shadows. Another way to look at this is if you have solar panels, just watch the current. output. Just as a single solitary cloud passes over. It's typically drops to 50% or much less. Or worse yet, on an overcast day, just try indoors reading a book without turning on the lights. It's just too dark, you can't do it. Where'd all that light go? It got reflected back out into space. Okay, this is a very important paper by King et al. And he analyzed 12 years worth of Terra and Aqua satellite data. And they made a very important part of the analysis where they separated out what happens over land and what happens over ocean. Okay, so the land is these red curves here. The black here are the over ocean, and the blue in between is the average. Okay, remember only 30% of the Earth is land. And you'll notice annual oscillations. Okay, so I have added power scales, just like I did early on, by multiplying by the solar constant, assuming the solar constant is constant. But there are two different scales, and they depend upon what I choose for the cloudy sky albedo. So this is the cloud fraction that is being measured here. Okay, so the left-hand scale, I just multiply the cloud fraction times the albedo and the solar constant, and I get that the fluctuation, just say worst case going from land to ocean, is at least 18 watts. Okay, on the right-hand scale, I use my more reasonable estimate of the cloud albedo, about 0.8, and there you get the order of 55 watts. A cloud that passes, say, from the Pacific Ocean over the North American continent. We all notice that the Pacific Ocean clouds are what control the North American weather. And so they all do indeed experience that 55 watts. Okay, and if you add in the additional fluctuation due to the Earth's orbital eccentricity, it's like the order of 77 watts is available power for this thermostat. Okay, and this is not slow. If you look, you'll notice that each of these curves here there's a dotted line and a solid line for land and for ocean. Those are for the Terra and the Aqua satellites, which were both in sun-synchronous orbits, went around every day across the equator the same time. One of them at 10:30 in the morning, and one of them at 1:30 in the afternoon. And the difference between those two curves is only 3 hours for the satellite passage, and that's the huge change that you got. It just did 3 hours time. So this is a very fast process. Okay. Now, if you compare this to the earlier Stevens paper, it shows that, and Stevens does not recognize this at all, that the albedo variation that he's observing is just simply due to cloud cover variation. Okay, so I think I sort of described earlier how this cloud thermostat works. Okay, so 73% is used on the oceans, is used for, the power is used for making clouds. It works exactly the same way the thermostat in your house does. It corrects the temperature in the presence of various heat leaks. that you have, volcanism, CO2, whatever, whether or not. Okay, so for comparison purposes, CO2 is asserted to have about 2 watts per square meter effect. Okay, so when the clouds are present, it turns the thermos off. When they're okay, that's why cloudy days are cooler in general than sunny days. Okay, if you have too much clouds, it turns the thermos off. You need that sunlight to evaporate water, the seawater. With reduced temperature, evaporation rate drops quite dramatically. It's a very, very rapid function of the air temperature over the ocean. And very quickly, the too high cloud cover starts to drop because the production rate has dropped. The clouds just disappear by precipitation and evaporation. So when the cloud cover is too low, it's exactly the opposite happens. So we have huge power available, and this happens no matter what the greenhouse gas levels are. So it'll immediately correct any losses due to greenhouse gases. Okay, let me go on to the third sacred task of the IPCC. That's to calculate and measure the strength of the feedback mechanisms. So it's pretty obvious that something is controlling the Earth's temperature. There are huge fluctuations. Mount Pinatubo explodes. It doesn't really have very much effect whatsoever. You can have huge inputs of CO2, etc. Nonetheless, the temperature and climate have remained incredibly stable. As in fact, the NOAA data show this. So they had a sacred task is to calculate the strength of the mechanism. And the fact that they did not correctly identify the mechanism led them to the wrong conclusion that the stability is quite marginal, that there is a tipping point for putting in too much CO2, and you would get a thermal runaway. That is clearly wrong. I'll show you here in a moment that the thermostat you get from the clouds provides an extremely strong stabilizing mechanism, a very strong feedback mechanism, and that the effect of greenhouse gases are totally negligible. Okay, so where has this been studied before? I mentioned earlier the National Academy report, 2003. There's another very important work by Sherwood et al., the so-called Ringsburg Castle study. And most of chapter 7.4 in AR6 discusses it. I use the methodology by Sherwood et al., the Ringsburg Castle study. They make an unnecessary assumption. They assume that the derivative of the cloud fraction, the cloud fraction is independent of the surface temperature. That cloud fraction does not affect, the surface temperature does not affect. It clearly does because it controls the production rate. So if you take that restrictive assumption out, you can recalculate that. I've got it in Appendix D slide for the questions if anybody wants to see it. And again, I had to choose two different choices for the cloud albedo, either the IPCC's choice or the more reasonable stuff you measure with a DZ3. Okay, so they claim they have the strength, the total, including all of the strength, is minus 1.16 plus or minus 0.06 watts per meter squared per degree Kelvin is the actual feedback strength. Okay, so I calculate that the total is the order of minus 5.7 if I use their cloud albedo, and minus 12.7, a whole order of magnitude bigger for the total. So, and I will show you those here. Okay, this is the top of this is taken straight out of AR6. This is the plotted on the left-hand side. The vertical scale is the cloud feedback strength. The straight line across the top here, that's neutrally stable. Okay, so here's what they calculate for the effect of clouds for the feedback. Here's what for depending upon using their assumed cloud albedo, and here's for what a DC3 measures. And so add those on to these other effects. Here is what I expect the feedback strength is. Here's what they think it is. Okay, so what are my conclusions here? First off, the cloud thermostat mechanism is the overwhelmingly dominant climate controlling feedback process. It controls very powerfully the Earth's temperature and climate, and it prevents global warming and climate change. The strength, they claim the strength is minus 1.16, and it's anywhere from minus 5.7 to minus 12.7. It's clearly the dominant feedback process. It gets its strength from a very powerful furnace for warming the Earth, being able to switch it on and off, anywhere from 40 to 77 watts. Okay. Importantly, this is what's referred to as a solar radiation management system. The IPCC has proposed we do cloud seeding, we do all kinds of totally crazy, outrageously expensive things. This one exists. It's built in. The nature's own cloud factory. The oceans are the cloud factories. It works very well to stabilize the temperature, and it's free. By comparison, the IPCC's mechanisms are going to, if you buy them, are going to cost you trillions of dollars per year. Okay, so a few additional technical details. Remember I mentioned that Ramanathan divided the sky into just two parts. It's very clear looking at King et al. Study, you really need four pieces. You need clear and cloudy sky over ocean and clear and cloudy sky over land. And the stuff over ocean, that's 70% of the effort right there. So those are the place to concentrate. The IPCC has clearly never mentions this huge variability, totally clueless. And they never even reference the King et al. Study. So if the IPCC can make recommendations for policymakers, so can I. First recommendation, there is no climate crisis. Now we clearly do have an energy crisis, especially because we have this huge population that somehow wants energy. And if you try to limit the energy production, you're just totally exacerbating the energy crisis problem. Said the government and business are needlessly spending literally trillions of dollars in efforts to limit greenhouse gases, CO2 and methane. One of the singularly most important things that can be done, and this was brought up, I think, earlier, is what you define as a pollutant. This was done by Lisa Jackson. Poor old Steve Chu was left with his head spinning. She was a straight power grab, so she could use the Clean Air Act to give her power to control all of this. You need to remove CO2 and methane from the list of pollutants. It is not a pollutant. It has a negligible effect on the climate. And just, you could save trillions of dollars immediately just by the simple redefinition. And as everybody here in the CO2 Coalition point out, CO2 is beneficial. It's good stuff. Okay, so they are mandating trillions of dollars to be spent. If there's a zero carbon policy should be immediately terminated. I recommend that all efforts to limit environmental carbon should be terminated immediately. Trillions of dollars could be saved. By just inflation alone will dramatically be reduced by stopping spending, wasting money. You got to get rid of carbon caps, carbon credits, carbon sequestration, carbon footprints, zero carbon targets, carbon taxes, anti-carbon policies, fossil fuel limits, electric vehicles, for case in point, and solar and wind power. If they are not economically viable on their own, then they don't deserve to exist. Fossil fuels are all perfectly okay to use. Okay, so any of these crazy geoengineering projects that are going to cost trillions of dollars a year, totally eliminated. Okay, and so my final comment is some of us remember Senator Everett Dirksen during the Vietnam War when he's complaining about spending for the Apollo program and the Vietnam War, and I've just updated it for inflation. $1 trillion here, $1 trillion there, and pretty soon you're talking about real money. Thank you. I still have time for questions, or did I use it all up?
We can, if you're willing to take some few questions.
Sure, happy to.
If you come up here to the mic, please. Thank you.
Oh, by the way, for one more, to stimulate additional questions, here is the proof of that theorem I heard earlier, that the total albedo is just area-weighted sum. Okay, here is its application to the numbers from AR6, and here is how I do calculate the feedback strength. Go ahead.
John, the cloud thermostat mechanism, the way you describe it, it sounds so stable. I don't know how we would have had a medieval warm period and a little ice age. So how do we...
I have the faintest idea what happened in the little ice ages, or we didn't have any satellites, we don't have any data from there. So I really can't... something important happened that we don't know about, I strongly suspect. But again, we don't really have any valid, sufficiently data to know what did happen. I don't know. I am told that some of the ice ages coincide with magnetic pole reversals, but I don't know that.
Okay. Also, is there some kind of specific test that can be used to sort of either support or falsify the existence of the mechanism? Can you think of a
Certainly, there are things that could verify the observations. My claims that the cloud production rate that is measured. The problem is that these satellites only pass once a day. And this is grossly undersampled because all of this activity is occurring within the day. Clouds over the ocean, they start forming in mid-morning and keep building until the middle of late, just before dawn. I know this from racing sailboats across the ocean. That's when you got these monster squalls that you would always have to avoid. So yes, there are any number of tests that can be done.
Okay.
A lot of these things that are readily measured. All you need to do is look.
Okay, we now hear of Bill Gates' insane project of seeding clouds. If that's done on a large scale, how would that affect this whole system?
Bankrupt us. There was a University of Washington was doing that in San Francisco Bay. They had some big. It looked like they were snow blowers, effectively, or cloud snow making machines. They just brought down, put them on the deck of the Hornet aircraft carrier in San Francisco Bay, and blew salt water up in the air, and it got the deck of the Hornet rather wet. And then the counter alarmists and the Alameda City Council stepped in and said, "Oh, we're afraid you're going to do something dangerous," so they shut them down. So all that will happen if that is used, as far as I can tell, is you will spend a lot of money and have no effect whatsoever. The simple business model you need to calculate is in order to affect the planet, you've got to affect a major fraction of the sky. How many ships do you need to put on the ocean to make clouds? And why bother when the Pacific Ocean does it itself very well? Yes.
I was going to say that I remember early in the debate, Dick Lindson having a big deal about clouds as well. I was wondering if first and foremost you interact with him on this issue.
No, I never interacted with Lindson. I'm not familiar with his work.
Oh, okay. Well, the second thing is, this is actually just a non-scientific question, but since you've kind of come out of the closet per se as a being skeptical,
I've only had two death threats.
Yeah, that's what I was going to ask you. How many phone calls are not being picked up now? Are you finding any pushback?
Well, if you remember, we just got back from this ICA conference in Vienna. Now, ICA is headquartered not in Vienna, but they're in Leipzig. And I asked, the reason they moved it to Vienna was they were scared for their lives against the major protests that would occur. Apparently in Germany, things get really rough. So.
Thank you for your efforts on the behalf of sanity here. I have a question related. Ed Berry is a physicist from Montana. You may know of him. And he says or claims that about 22% of the increase in carbon dioxide into the atmosphere is caused by humans, and that about 80 or 75% is of natural sources. And he bases that on the half-life of CO2 in the atmosphere.
Could be. I'm not familiar with the details. What I point out here is that I don't really care.
Well,
I mean, it doesn't matter. Number one, it doesn't matter whether it was man-made or natural. And number two, either way, it's negligible.
Yes, but the effort to sequester CO2 is something that is very expensive. And if 80% of the CO2 is from natural origins instead of by humans, then you're definitely fighting a losing battle, even though CO2 is not relevant. And I think that's
I'm sorry, what was it? What's the...
Okay, what I'm saying is that if 80% of the CO2 in the atmosphere is of natural origin and not produced by humans due to the half-life of CO2 in the atmosphere, which may be as low as 5 years according to Barry, then we've got people that want to sequester CO2 when it has nothing to do with human production, virtually nothing. And it's a great waste
I'm sure
of money.
they have their reasons, yeah.
Yeah. Well, what their reason is because they think CO2 endangers the earth.
Right.
So,
I don't.
well, neither do
Obviously.
I. Thank you.
Now, but probably by far, if you really want to see, probably by far the cheapest way, by the way, if you want to sequester CO2. I mean, go to any bar, it's got a tank of CO2 there. It's all in liquid form. It liquefies at surprisingly low pressure. You just pump it into a tank, and then you just take it out on a ship in the ocean, and you dump it into the ocean. So the deep ocean, and you don't need to go very deep to put it into just hang down a hose and move along and dump out all this liquid CO2. It'll stay liquid at that pressure. So maybe some of the deep ocean fish will be drinking soda water rather than just normal salt water. But that's by far got to be the cheapest way to get rid of it. And it'll stay there, I mean, which is where nature's going to put it anyway.
A couple of quick questions. How is it that these so-called, I use air quotes around climate scientists, make these glaringly obvious high school level arithmetic errors in their calculations of the energy imbalance, and those papers, A, don't get retracted and don't get, shown for the ridiculousn's that they are? That's my first question.
I wish I knew, as what I started out on my very first slide, dishonesty. They are presumably being pressured to do so by political entities. I don't know.
And how do you...
Fortunately, I am not one of them.
Well, that was sort of my next question. And how do you feel about these scientists who claim that you shouldn't be talking about this because you're just a physicist?
I don't know how to answer that. Physicists get to have their... Okay, one of the things I do notice that I sort of didn't expect, and partly the reason I'm here, is that if they give you a Nobel Prize, that gives you a license to be a referee.
Okay, we'll take one more question.
Years ago, when I gave up government consulting on modeling, I started looking on how do we know what we know. And of course, I knew about the scientific method, but no one really taught it well or what have you. And it wasn't until I read Richard Feynman, a quantitative theorist, that it really came together. Nature is the ultimate and final judge of all science, physical science. My question to you is it, assuming it's not in the water you drink, is it something about the way quantitative theorists approach problems that allows them to cut through an entire web of error and...
It's not theorists, just physicists in general. I claim to be both a theorist and an experimentalist. I've done some of both, which is actually a marvelous position to be in. But Feynman was famous for noticing that the O-rings in the Apollo rockets got cold when you put them on the we can see the elephants in the room that are hiding in plain sight.